dative covalent bonding. Dative covalent. Dative. Now look at how they call it in syllabus. They call it what? Look at this. What they call it in your syllabus. We are here. They call it coordinates or dative covalent. Do you get? So in dative covalent or coordinate bonding, what are we doing? It's like normal covalent bond. Only that the person that brought the 2 electron, only one person brought the 2 electrons that shared. The other guy just shared, didn't bring any. The simplest compound I'll give you this guy. Look at this guy. Carbon, oxygen. What group is oxygen? Group 6. Oxygen normally have two electrons shared. Am I right? Yes. And it has 4 left unshared. That's oxygen. Carbon now. Carbon says, oxygen, see you brought 2. Me, I also bring 2. And I'll keep 2 to myself. But if they bring 2, overall now, how many do oxygen has overall?
8.
What about carbon?
Carbon now has 6.
Carbon is not complete. You will now beg organize oxygen. You bring these 2. Remove them from there. Put it between me and you. Carbon will now put the 2 here. Can you see now? They both have it now. This is simplest covalent. How do we draw it? We draw like this. We draw like this. It's drawn this way so that you can understand it. Carbon, covalent bond, dative covalent bond from oxygen to carbon. You must show the arrow. The arrow shows that it's from oxygen to carbon. Then oxygen. Now only 1 lone pair on carbon, only 1 lone pair on oxygen. Can you see now? Do you get it?
Yes.
That's dative covalent. How many bonding pairs?
3.
What about lone pairs?
2 pairs.
Thank you. No, yeah, and this is one. Number 2. Ozone. Let me draw ozone for you again. Ozone molecule. Ozone is this 3 oxygen atoms. 1, 2, 3. Oxygen. They are both group 6 elements. All of them. They both have 6 electrons. This guy will say, yeah, let's share 2, and me, let's share 2. 1, 2. I keep 4 to myself. 3. Is that okay? That's first. Okay. Second one now say also let me do the same thing. 1, 2. And I have 4 left for myself. Toxins now say, me, I'm coming. No. I can't share anything with you. I'm already full. It's okay. You keep your 6 to yourself. 1, 2. Keep your 6 to yourself. 3, 4. He said, but I'm not complete. He said, don't worry, I'll help you. I'll help you. Don't worry, I'll help you. You will now take these 2 and put it in between both of them. Now put it here. So everybody's 8. Everybody's fine. Now can you see now? So how do we draw this? How do we draw it? Draw it like this. Oxygen, double bond, oxygen, dative covalent bond, oxygen. This guy has 3 lone pairs. This guy has only 1 lone pair. This guy have 2 lone pairs. Do you agree?
Yes.
So that's ozone for you. So I did a simple compound in element. We have either in carbon dioxide. Then this compound is also very common. It's very, very common in multiple choice. Of course, this is O3, ozone. This is CO, carbon monoxide, right? The other compound, NO. Look at N2O. What do you mean by what is N2 to start with? What is N2? N2 is 1 covalent, 1. Is that not N2? Lone pair. We now want to form N2O. You now say, okay, just come, don't worry yourself. Keep your 6 to yourself, don't bring any. Let me use this one to form dative bond with you. Now from this, can you see now?
Okay.
Such that the nitrogen in the middle now does not have a lone pair again. Do you agree? So how do you do this and dot and cross? N O O N N 1, 2, 3, 4, 5, 6. 1, 2, 3. So you can now brought his own 2 here. The tip point. Now so you keep your 6 yourself. Can you see that? Everybody is happy. Can you see now? So these are common examples that you have to figure. And they give you that one, you have to figure them out. Now, now say you should know the one I've done for you. I've drawn the one of ammonia and HCl. I've drawn the ammonia. Ammonia is like this. The lone pair. One to react with HCl, which is H plus. Actually, one to react what? Look at HCl. HCl. This guy now first break up into what? H plus, then Cl minus. How many electrons will Cl now have? 7. How many electrons will they have in the outer shell? Normally, chlorine has 7 electrons in the outer shell. No, look at it. 1, 2, 3, 4, 3 lone pairs. And you now have 4. You now have how many lone pairs now? 4 lone pairs. Do you agree? Because the bond between H and Cl goes to chlorine. Why? Chlorine is more electronegative than hydrogen. Do you agree? So C minus has 4 lone pairs. Do you agree?
Yes.
Now, this hydrogen now go to the ammonia and form what? Ammonium. So first of all, have NH3 with H plus. What will be the answer? H dative bond NH H. Is that ammonium? Do you agree? It must carry an overall charge of plus. I want to put chlorine beside it. It must carry an overall charge of plus. So the answer will be NH dative bond H ammonium. Then the chlorine now come here, chloride. Skimmy now said question 1. State all the bonds present in ammonium chloride. And yeah, the question is state all the type of bonds in what? In ammonia. Can you start telling me? Number 1, covalent. Do you have covalent bond?
Yes, 3.
Between what and what?
Between the nitrogen and hydrogen.
And H. Do you agree?
Yes.
What about the covalent bond?
Yes, we have 1.
Between what and what?
N and H.
Thank you. Do you have a unique bond?
Yes.
Between what and
ammonia and chlorine.
No, between ammonium and chloride. Not chlorine.
And chloride.
Do you get the point now? Can you see now? So that's going to go 3 marks. Paper 4 question. Set out the bond and tell her where they are found. Simple as it is. Is that okay? So
yes.
I'm sure that now it is so. But now there's another compound. Look at this. So how do we form ammonium chloride? Ammonia and HCl. This compound NaBLiAlH4. It's actually between what? It's actually between what? Lithium hydride and aluminum hydride. Unlike here, where ammonia has lone pair to donate to H plus, here is the other way around. This one breaks into Li plus H minus has a lone pair. Do you agree? H has 1 electron. Chlorine now gave him, lithium now gave you another one. Is that okay? So essentially, H plus has a lone pair. But in AlCl3, Mr. Aluminum does not have complete octet structure. Do you remember that? Mr. Aluminum, you don't have complete octet structure. You are not complete. So what do you think will happen here? Look at it. So AlH3, HAlH plus H minus with a lone pair. What will it give us? It gives us H is the one that donates to aluminum now. Is that okay? It's coming down. Unlike the
Okay.
other one, ammonia donate to H. This guy H one that donate now, right?
Mm.
They are not complete to aluminum. That's the only difference between them. H, H, and H. The H that came in was a minus, so this guy will carry minus overall charge. Do you agree?
Mm.
Then lithium will now say, me I'm plus, so I'm staying behind you. Can you see now? That's compound. Again, all the three bonds are present here. Covalent bond between Al and H. Basic covalent bond between what? H and Al again. Then ionic bond between what? Al4. Ionic between what? Ionic between what? Al H4 minus and Li plus. Do you agree?
Yes.
Good, that's it. So the game command, you need to sort out many other things. Then finally, let me show you this compound. I have the tip one also. Nitric acid, I mean, well, HNO3. HNO3, look at it. And who is having two bond, lone pair is okay. You now form bond with this guy. O and H. He now has a lone pair. Nitrogen, how many bonds does he have? Nitrogen must form how many covalent bonds? Three covalent bonds. It is formed already. Do you agree?
You're saying
Nitrogen must form three covalent bonds.
yes, 3.
And after that, you now have one lone pair. Is that correct?
Mm.
So it has formed three covalent bonds. Is it a normal compound or not? Yes. You now want to become HNO3. O says, I'm coming to you, I'm joining you. Let now say, just keep your oxygen, keep all your electrons to yourself. Oh. I don't need your electron. Oh. Keep your 6 electrons, keep them to yourself. Let me just form a dative bond with you. Now from this, can you see? That's HNO3 for you. Are you sure you understand this? The lone pair on N is to form bond with them. Just like the way this guy did. Look at the N2O. Remember, look at N2O. Where is N2O? Nitrogen formed dative bond with oxygen coming. Am I right? Oxygen,
Yes.
assist yourself. Don't bring it. Just keep yourself. I'll just share two of my own with you, and everybody will be fine. How to do it? Same thing with this guy, HNO3. Who says something, keep it yourself. Let me just share my dative bond with you. Do you get? And they're fine.
Okay.
Do you understand?
Yes.
Do you understand?
Yeah.
So if they have to draw that across of this, you can draw it to be N.
Okay.
N. O. O. H. Then the other O. This other O is not conventional. Keep his C to himself. 1, 2, 3, 4. As nitrogen is one, nitrogen now brought 2 here. Then the other O. 1, 2, 3, 4. Nitrogen now keep here. Then O also. Then O. Then O and hydrogen. Can you see?
Yes.
Show me where is dative bond there? This is dative bond. This bond. Right. That's dative bond. Is that okay? Nitrogen brought it too. Do you get the point now? It's just here with hydrogen. Does it make sense?
Yes, it is.
Thank you so much. So that should do. We have done ammonium. I've done this for last week. Am I right? They only said you do 2 examples, and I've given about 6 examples. I think I'm good, right?
Okay.
Number
Yeah.
2A now. 2A. I'm writing them so that you can locate them. Learn outcome 2A. What? We are on 3.428. So we are reading. You can 3.42A. Can you please read? What is your learn there?
Describe covalent bonds in terms of orbital overlap, giving alpha and
No, sigma. That was called sigma.
giving sigma and
This is sigma.
pi
This is pi.
bonds.
Thank you. Sigma and pi. Now, then pi bond are formed. Okay, let's go. This is what happened here. I think I have a note here. Let me show you. It will be easier for me to explain to you here than me writing everything again all over. Okay. Yeah, look at it. Further description of covalent bonding. So I'll call it there was sigma and what? Pi bonds. Sigma and pi bond. Are you there? Let's go.
Yes.
Now, when you form a bond between two atoms, when you form the first bond between two atoms, that first bond formed is a sigma bond. Any other bond formed after that is a pi bond. Look at it, sigma and pi bond to start with. So look at this. Look at this. In methane, we have 4 sigma bond in methane. Is that okay? 4 sigma bond. Are you there?
Yes, sir.
In ethane, how many sigma bond do you have in ethane? I mean, in propane. How many sigma bond do we have here? How many sigma bond do we have here? 1, 2, 3, 4, 5,
8,
6.
4,
What
5,
about the one
6.
between carbon and carbon? You didn't count that?
So it's 8.
No, you only counted carbon and hydrogen. What about carbon and carbon?
9.
10. How many carbon hydrogen?
2, 4, 6.
How many carbon hydrogen bond do we have in this molecule?
When you say carbon, hydrogen, I'm also counting the ones by the side.
All the carbon hydrogen bond, all of them.
8.
8. Then how many carbon?
3. 2.
Thank you. So how many sigma bond? 10 sigma bond.
Okay.
Do you understand?
Mm-hmm.
Yeah, look at this. SF6. How many sigma bond? How many sigma bond?
5.
Count it well.
1, 2, 3, 4, 5, 6. 6 bonds.
6
6
sigma
sigma
bonds.
bonds.
Is that okay?
Mm-hmm.
Now I'm now doing something. Oh, this pen again. Hold on. Hold on. If I touch this down. Okay, thank God it's working. So 6 sigma bond. Now let me now do something. Look at this. 1 sigma bond. 1 sigma bond. 1 sigma 1 pi. Just so that I'll write it down now. 1 sigma 2 pi. So let me state them out here. Sigma pi 1 0 1 0 1 1 1 2. Between two atoms, you can only form 1 sigma bond. Any other bond formed after the first one is a pi bond.
Okay.
Focus on 2 atoms per time. You can only form 1 sigma bond. Any other bond formed after the first bond is a pi bond. Do you get the point?
Mm-hmm.
Good. So sigma and pi. Now let's do carbon dioxide. Therefore, let me do hydrogen cyanide. Hydrogen cyanide. Carbon dioxide. Ethyne. All those bonds are sigma. Now let me fill it up. Pi bond. 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 Do you get? So all this one, they are pi bonds. Are you there?
Yes.
Then all this one, they are sigma bond. Do you understand it now?
Mm-hmm.
Have I settled it? So the first bond formed between two atoms is a sigma bond. Any other bond formed after the first bond is a pi bond. Is that okay?
A lot, and you're like, okay, do you have a private tuition? don't you have, do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2024, 5, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Yes.
Good. So sigma pi bond. Now, how to form sigma bond? See, when sigma bonds are formed, the atomic orbitals actually overlap. They overlap, as in this. They overlap very well. They overlap very well. Sigma is sigma. Pi may not be like this. Can you see they didn't overlap very well?
Yes, I see
Sigma,
it.
look at the extent of overlap. Look at the extent of overlap here.
It's
The
more.
overlap is much. So sigma bond overlaps very well. So it is stronger when they are formed than pi bond. Pi bond did not overlap very well. So can you read now? Can you read? Yeah, now it said 2a. Sigma bond are formed by direct overlap of atomic orbitals in bonding atom. Therefore, it is usually strong. Is that okay? Sigma bond. Now look at the example I gave you now. All this one, say all of this guy, they have sigma bond only. Here, sigma is 1, pi is 1, sigma 1, pi 1. So this guy is sigma, sigma, pi, pi. Do you agree? So you can see the example I gave there. You understand them now? Look at this guy. How many sigma, how many pi? Pi, do you agree is 5 sigma, 1
5
pi?
sigma 1 pi. Yes.
And the next one, and the one next, 1 sigma, 2 pi, and the one next In carbon monoxide, so there's a that dirty covalent bond there. Is it a sigma bond or pi bond? Is a pi bond. The first bond formed is this. So any other bond form is a pi bond. So in carbon monoxide, we have one sigma and two pi bond. And that guy we have that. Is that okay? Do you get that now?
Yes.
Now, how do you form sigma bond? Now, sigma bond is formed. I want to write a sigma bond. Sorry. Now, sigma bond is formed by direct overlap of atomic orbitals. Therefore, sigma bonds are usually stronger than pi bond. Is that okay? I want to copy this so that it will save my time instead of writing it out. Now, hold on. Okay. Good. Sigma bond are formed by direct overlap of atomic orbital between the bonding atom. Hence, it's usually stronger. Hence, it is usually relatively stronger. Relatively what? Stronger. Is that okay?
Yes.
What about pi? Where about pi bonds? Where about pi bond?
Are formed by sideways overlap of adjacent p orbitals above and below the sigma
The
bond.
sigma bond. So it is not as strong as pi bond. Pi bond is what? Relatively what? Weaker. Therefore, easily broken. Is that okay? No story. Now, to prove this point, let me go to your look at it. In the booklet, they said carbon-carbon single bond. They said the value is 350 kilojoule per mole. Are you there?
Yes.
That's a carbon-carbon double bond. Is 610. What is the value of a sigma bond here? Sigma bond here, sigma here is 350. Sigma here is 350. And the pi bond form should be 210, 260. Do you agree? To make it 610. Sigma is 350, it doesn't change. If that's a sigma and pi is 610, that means pi is weaker, is 260. And the more the pi you have, the weaker they become. Look at it now. When you now come to this guy, they say it's 840. If sigma is 350, what's now pi now? Move 350 from 840. What do you have?
Let me use my calculator here. I don't have it with me.
Is it 490? 490, yeah. 490. And there are two of them over 2. What's the answer now? 245. Can you see? When it was one pi, I'm just saying that pi bond are weaker than sigma bond. And the more the number of pi bond you form, the weaker they become. 245. Can you see now? Kilojoule. Can you see now? Sigma bond is 350. When you have sigma and pi is 260. When you have 2 pi, you become weaker again. Is that okay? So the more pi bond is weaker than sigma bond. The more the number of pi bond, the more the number of pi bonds, the weaker they become. The weaker the pi bond they become. Do you understand that now?
Yes.
When I now come to organic chemistry now, I'm going to tell you that alkene are more reactive than alkane. This one is alkane. This one is alkene. This one is alkyne. Question 1. Why is alkene more reactive than alkane? Alkane has a pi bond, which is relatively weaker, therefore can easily break. Is that okay?
Yes.
Why are they more reactive than alkane? Alkyne has 2 pi bond, each of which is weaker than a pi bond in alkane. So can easily break. When the bond can easily break, that reaction can easily occur. Do you agree?
Yes.
When a bond can easily, reaction can easily occur. So sigma bond are stronger, pi bond are weaker. Simple as this, no story. Now let's go. Describe how to form sigma and pi bond in this guy. Now, can I do something for you? This thing to waste my time. I'll write the note and send it to waste my time. Please, I mean it. It takes time for students to grab it. It will waste my time. Please, I'm skipping it.
Okay.
I'll write a note and I'll send it to you on the note. You read the note for me first of all.
Okay.
Leave it. I'm skipping. It will waste my time. I mean it. It will waste my time. I don't like teaching it on time. Ask me. Now, next one. About 3A now. Go on. You know what sigma and pi bond are now, right? They by now see one yet said, yeah, look at this. They give them one big. He said, look at this molecule. This molecule. How many sigma, how many pi? Molecule is big. I think I can how does it look like? I'm coming over. Yeah, okay, look at this. Yeah, SO3. How many sigma, how many pi? Then CH3,
Okay.
CO, CH3. How many sigma, how many pi? Then, I don't know. Then S H2SO4. H2SO4. Yeah, let's go. How many sigma, how many pi? Yeah, let's go. Sigma and pi. Yeah, let's go. How many sigma? 3. How many pi? 3. Agree.
3.
How many
Yes.
sigma here?
1.
Each of the carbon has 3 sigma. Do you agree? CH is 3 sigma. CH is 3 sigma. Then this one, sigma also. Sigma, and one of these is sigma. So 9 sigma. 9. Do you
9.
agree? 9.
How did we get to 9? You said each has 3 or
This
3,
guy has
6.
3. This guy has 3.
Okay.
Then this guy, then one of this guy.
Yes.
Do you agree is 9? 3 on CH3, 3 on CH3, then carbon on the left, right and left 2. What about one of the carbon oxygen, sigma? You are not getting it.
I'm getting it.
Do you understand why it is 9?
Yes. 3
Then how
there,
many
3
pi?
there, and then the side ones.
Yeah. What about sigma here? Sigma 1, 2,
2
3, 4, 6 pi 2.
and 2.
Do you get?
Yes.
So they give you and say how many sigma, how many pi. You need to identify that. But I've skipped hybridization for now. I've skipped that to save my time. Next one.
Okay.
Next one. Yeah.
Define the terms bond energy as the energy required to break 1 mole of a particular covalent bond in the gaseous state.
Now I need that data booklet. Why is it not available here? Bond energy can be exact and can be average. There are two types of bond energy. Pay attention though.
Yes, sir.
So you say bond energy is energy required to what? To break 1 mole of a particular covalent bond in the gaseous phase. So yeah, let's go. What's bond energy of hydrogen? H2 gas. Am I right? To become 2H gas. What about chlorine? Cl2 gas to become 2Cl gas. What value for HH? 436. There's only one type of HH bond plus 436. So it is precise. We are saying that the meaning is this: 1 mole of this to become 2 moles of this. You have 2 moles of what? Hydrogen. Do you agree? This is energy required. You have 1 mole of hydrogen gas to become 2 mole of hydrogen atoms. This is energy required. Do you agree to that?
Yes.
How many molecules are in 1 mole?
How many molecules are in 1 mole?
Yes, ma'am. I've got this number.
6.02 times 10 to the power 23.
So bear that in mind. Bear that in mind. Again, chlorine and chlorine. 1 mole of chlorine gas to become 2Cl gas. Enthalpy change. Bonding equal to 4, 2, 2, 4. kilojoule per mole. Is that okay?
Yes.
That's the bond energy to break 1 mole of gaseous covalent bond. The reactant must be gaseous. Now look at this one. Now this one are what? They are exact values. Why? There is only one type of hydrogen, one type of nitrogen, one type of oxygen. Is that okay?
Mhm.
But when it comes to this one, look at when it comes to this one, there are many types of carbon. Do you agree? What that means is, look at this carbon with a double bond and H. This carbon bond. How about this carbon bond in ethane, propane? The value of carbon here cannot be the same as this one exactly. They are not. You get they differ. Because is next to oxygen. This one is not next to oxygen. So the carbon here, the value may be 348. This one may be 348.6. Is that okay? Then the carbon, do you get the point? They won't be exactly. Because they're not the same thing exactly. So we say all these one are what? Average values. But the
Okay.
former one are what? Exact values. There is only one type of hydrogen fluorine bond. There's no average anywhere. There's only one type of hydrogen chlorine bond. One type of hydrogen iodine bond. There's no other special type. Is that okay? But there's one type of CO bond, carbon monoxide bond. Is that okay? But this one,
Yes.
where can we have? Let me give you a better example. Where is OH? Where can you have OH? Let me show you. You can have OH. Let me write it here. OH bond. Bond energy is what? Is average value. Am I right?
Mm-hmm.
What is average value? Let me put it to you. You can have OH in water. Am I right? You can have OH in hydrogen peroxide. You can have OH in sulfuric acid. They are not all the same value exactly, all of them. You can have OH in hydroxylamine. You can have OH in nitric acid. There are many OH value. All of them, when they find the average value, what is the average value for OH? 460.
460.
So 460 kilojoule is not exact. Some are exact, some are average. Is that okay? You don't know the third two in secondary in GCSE, endothermic and exothermic reaction.
Yes.
Bond breaking is endothermic. So the meaning is this. Bond what?
Breaking.
Breaking is what? Is endothermic.
Mm-hmm.
Bond forming is what? Exothermic. The meaning is this. Cl plus Cl to give Cl2. Then temperature will be what? Minus 224 kilojoule per mole. But Cl2 to become 2Cl. We are breaking bond. Then temperature is what? Plus 224 kilojoule per mole. Do you understand that now? First one is bond making, exothermic. The second one is bond breaking, endothermic. Which one represents the bond energy, the first or the second?
Which one represents what?
The bond energy. Come back here. Read the bond energy. What is bond energy?
Bond energy is the energy required to break one
To
mole
break,
of.
to break, to break. Which one represents the? This is the bond energy. Do you agree? Breaking of bond is bond energy. Is that okay? Not forming of bond. But we are just saying that if the forward reaction is plus 224, then the backward will be minus 224. Do you get a point? If the forward is endo, then the backward should be exo. The same value exactly. Do you get it?
Yes.
Now, next one. So now bond
Bond.
energy now. Come back, bond energy, still on bond energy. Let me give you a practical example. FF bond energy, OO bond energy, NN. FF is what? Let's go and see FF. FF is what? Where is it? 158. 158. O is 496. The 4 O double bond O 4 yeah.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
N1N 944. So which of these molecules will be most reactive and why? Bond energy versus reactivity. Which of them be most reactive and why?
I think it's the NN, because it has like two pi bonds.
Okay. Now, when you compare please pay attention. It's very important. On organic chemistry, you don't have to break all the 3 bonds for the molecule to react. When the pi bond breaks, the molecule will react. Is that okay? But here, for nitrogen to react, you have to break all the 3 bonds.
Okay.
For O to react, you have to break the 2 bonds. So based on that, what happened? This way, bond energy increases, and reactivity decreases. Is that okay? So you have to consider the whole bond energy here, not separately.
Okay.
That one I showed you before was for organic chemistry. In organic chemistry, you don't have to break all the bonds before the guy can react. When one of the bonds breaks, the guy will react. But for nitrogen to react, you have to break all the 3 bonds for it to react. So you can say that bond energy is what? Is invariant to what? Bond reactivity. You agree to that?
Yes.
Bond energy when it's high, the guy fluorine is much more reactive than oxygen. And nitrogen is almost unreactive. It's just in the air, it's not reacting. The bond energy is too high. Therefore, large amount of energy is required to break the bond. So the guys, I'm not reacting. The meaning is that it will have high activation energy. You know what activation energy is? Am I right?
Yes.
You have high because of the high bond energy. Do you get the point now? So
Mm.
that's about that. Now, what about bond length again? Bond length. What's bond length?
Define the terms bond length as the internuclear distance of two covalently bonded atoms.
Thank you. Yeah, let's show example of that. Yeah, let's go. Bond length. I'll give you example. Bond length. The example I'll give you is HF, HCl, HBr, HI. Why is the bond length? Why is it increasing down? Yeah, look at it. H. No. Why is the bond length increasing? H fluorine. H chlorine. H bromine.
Because now the atoms are
You have to
nucleuses.
ignore hydrogen. Focus on the halogen. Ignore hydrogen. Doesn't change. Focus on the halogen. Why is there an increase in bond length and the group? Because atomic radius of the halogen atom is increasing. Do you agree? Due to increase in number of shell. Do you agree? There's
Yes.
an increase in the number of shell of the halogen. Therefore, atomic radius is increasing and bond length is also increasing. Is that okay? Do you get the point now? So now
Yes.
let's go and see the value of the bond length in your data book. H plus HF 562, HCl 431, 431, 366. I think 299. Yeah, I'm right, 299. Why is the bond length energy decreasing and decreasing? Look at it. Nucleus of hydrogen. Remember, covalent bond is due to what? Attraction between the nuclei and the bonded electron. Do you remember? Electrostatic attraction between the nuclei and the bonded electron. Now look at the nucleus of this fluorine. Nucleus is here. Electron, electron. Look at the second one. Hydrogen. Chlorine is now here. Nucleus, nucleus, electron, electron. Now next one. Nucleus, nucleus. Which of the nuclei we attract electron the most? The one on top or the one down?
Which one or what?
Which of the two nuclei we attract electron the most? The one on top or the one down?
Down.
The one that attract electron the most. Nucleus is positive, electrons are negative. This one is very far from it now. We won't be able to attract it so much. Do you agree? So yeah, number of shell of halogen increases, right?
Yes.
Second point, atomic radius of halogen increases, right? Distance of the nucleus. Distance between two nuclei. Distance between the two nuclei. Distance between the two nuclei. Distance between the two nuclei increases. Bond length increases. Bond length increases. Bond energy decreases. Bond energy decreases. Reactivity increases. Reactivity increases. This means pay attention. Oh. Bond length, if it's very long, lower bond energy and more reactivity. The longer the bond, the lower the bond energy. Do you agree?
Mm.
And the more reactivities.
Okay.
The lower the bond, the longer the bond, the lower the bond energy, the more reactivities. Do you get it now?
Mm.
The longer the bond, the lower the bond energy, the more reactive is the bond. The more reactive is the what? Is the bond. Is that okay? Can you see? HI is very weak, HF is very strong. So the meaning is this: you want to react this guy in organic chemistry. You want to react this guy with HCl with 2HI. They all react, both of them will have to give you CH3, CH2Cl, CH3, CH2I. For them to react, you have to break the hydrogen-halogen bond. Which of the hydrogen-halogen bond will easily break? HI. Therefore, this is more reactive. Do you get the point now? HI is more reactive in this case because the bond can easily break. Is that okay? How about this one? F reactive. Actually, HCl is reactive. I won't say less reactive, but HI is more reactive. Do you get the point now? This one is what? Let's just put reactive. They are more reactive. Do you get? Because none of them is slow. Both of them are very fast. But HI is faster. Do you get the point now? Why is HI faster? HI has a lower bond energy. This is bond energy here. Bond energy. Therefore, one can easily break and everybody can easily react. Do you get the point now? So then now, so you bond energy. That can you see now? You read this. What they say?
Use bond energy values and the concept of bond length to compare the reactivity of covalent molecules.
We have said that when the bond energy is high, meaning is high bond energy. What does that mean? Lower reactivity. I mean, lower reactivity. Am I right?
More distance. Yes.
Longer bond length. What about longer bond length? Longer bond length. What does that mean? It means lower bond energy. Lower bond energy. And therefore, greater bond reactivity. Greater bond reactivity. Is that okay? Okay, that's settled. I'm done with that. Now, let's see the next one. Now, shapes of molecule. Then there's one I drew for one student. I've discussed it. I'll just send you. If you want to go by, look at this. Can you see? Can you see my screen?
Yes, I can.
I will send this audio to go over it. You have to do other than cross. I think we have done this now, right? Good. So I just given examples here, so you can just go over it.
Okay.
So all this one I said they contain date equivalent bond. The one I said, the one I put a dot on, they contain date equivalent bond. You can just go over them. HOCl. Then some of them have expanded octet. Is that okay? So good. Let me put it in your folder. I don't want to forget. Now, next in your syllabus now is what? Shapes of molecule. Now, covalent bond. Now, look at it. This when I said covalent bond are directional, what do I mean by that? Let me explain to you. When
Okay.
say covalent bond are directional, we mean look at it. When ammonia, so shapes of molecules. When ammonia was to react, look at ammonia, I wanted to react with H plus. H plus, where will it come from? From the top or from the down? Why? And why?
You're
H
saying
plus, I
where?
want to join ammonia. The H plus, I want to join ammonia to form a dative covalent bond. Will it attack ammonia from the top? The way I drew ammonia, look at where I drew my ammonia. Will it attack ammonia from the top or from the bottom?
The top.
Why?
Because of the lone pairs.
That's where the lone pair is. Yeah? Say, Mr. Man, you pay you saw my lone pair, come from the top now. So covalent bond are directional. Do you get the concept? Do you mean of that word now?
Yes.
You can't just come from anywhere you like. You come from where my lone pair is. Then again, now look at this again. Ammonia want to react with BF3. Then you have proved that BF3 does not have lone pair. I mean, it has an empty orbital, BF3. How should the bond be formed? Lone pair from N must face empty orbital from who? From boron to form a dative covalent bond. Do you get the point now? You have bring your empty. You can't just when I want to attack you now, I'm the ammonia, you are the BF3. I'll say, Kamunda, where's your orbital? I say, it's under my leg. Can you see under my leg? You're going to attack him from my leg. Do you get the point now? Covalent bond don't just form, they are directional. They are specific in the way they are formed. That's why covalent molecules are live molecules are covalent molecules, which have definite shape. Now you said enzymes have an active site. Why? The shape of the active site of an enzyme is so specific that only some molecule can be admitted and some will not be admitted. Do you get the point? Now they will go away. They won't go work. Does that make any sense? So my point is that covalent bonds are very directional. Therefore, they assume definite shape. Now, I think I put in the notes. Let me see. Shapes of molecule. Can you read this, please?
The overlap of orbitals during covalent bonding is directional, and covalent molecules therefore assume some specific geometry and shape.
They assume shape. When you are reacting, when you are combining sodium chloride together, look at the sodium chloride, it can be like this. So look at the sodium. The chloride can come from the top. Sodium chloride can come from the side here. Can come from the bottom. They will affect themselves. It doesn't matter where it come from. So they can come from the back. Can you see now? Anywhere they come, they will attack themselves. Not so in covalent molecule, not so. Because they involve overlap of orbital. The two orbitals that must overlap, they must come in the same direction, even though there won't be any covalent bond. But here it is just an attraction between positive and negative. Anywhere it comes from, they will attract themselves. Do you get the point now? You can attract themselves anywhere. The covalent bond is not so. Is that okay? Now, how do we do shapes of covalent molecule? Number one, can you begin to read? Hold on, let me see that. I put it there. Number what's first shape? You want to consider what's first shape? Shape one, linear. What is the condition for linearity? Linearity for me. Two centers of what?
Two centers of bonding pairs.
And
absence of lone pairs on the central atom.
Now, you please say that again. Read it again. Do it again.
There are two centers of bonding pairs and an absence of lone pairs on the central atom.
Come back here. What some molecule I put here now? I said, look at sulfur. What group is sulfur? Group 6. It shares 3 with nitrogen, 3 with phosphorus.
Yeah.
How many lone pairs on the sulfur now? None. Now you saw the 6. Now, how many direction of bond do we have? Look at it. Pay attention, please. Where is the direction of bond? I mean, I mean, there is one going this way and now going this way. Do you agree? Two direction of bond.
Yeah.
So this molecule, PSN, I don't know if it exists too. But if it does, it should be linear. I'm trying to teach you the principle of linearity. Look at sulfur again. Shares
Mm-hmm.
with nitrogen. Sulfur has two centers of bonding pair. One follow this direction, the other follow this direction. Am I right? And there is no lone pair on sulfur again.
Mm-hmm.
Now, okay, now let's go for real example. Yeah, look at hydrogen cyanide. What group is carbon? Carbon is what group?
5.
No, group 4. Carbon is number 6. It's 2, 4.
Oh, good for.
Do you agree?
Yes.
It shares 3 with nitrogen, 1 with hydrogen. Does it have anything left for himself? Carbon is a group 4 element. It has
Uh-huh.
4 electrons in the outer shell. Out of
Mm-hmm.
those 4 electrons, it shares 3 with nitrogen, 1 with hydrogen.
It doesn't
Does
have
it,
any left.
does it have any lone pair again?
No.
How many direction of bonding pairs do we have here? How many direction of bonding pairs do we have here? Thank you.
2.
So HCN is a linear molecule. I'll take one by one, don't rush. Look at carbon
Okay.
dioxide. Carbon dioxide. What group is carbon? Group 4.
Mm-hmm.
After sharing 2 with oxygen on the right, 2
Mm-hmm.
with oxygen on the left, do carbon has any electron left again?
No.
The carbon dioxide is also linear. Is that okay?
You're
Look
saying the
at it.
carbon dioxide has what?
It's linear. It's linear.
Linear. Okay.
Linear. We are doing a linear shape.
Mm-hmm.
What group is both? What group is beryllium? Group 2.
Uh-huh.
Group 2. It shares one with chlorine. One with chlorine. It doesn't have an electron left again. Linear. It shares 3 with nitrogen on the left. It now shares the
Uh-huh.
remaining 2 with oxygen on the right as a dative bond. Linear.
Mm-hmm.
All these molecules here, they are linear molecules.
Linear molecules. Okay.
What group is boron? Group 3. It
Mm-hmm.
shares 2 with oxygen, 1 with
Mm-hmm.
hydrogen. Any electron left again? No. Linear.
Mm-hmm.
All these molecules are linear. What are the conditions for conjugate to be? What are the 2 conditions for something to be linear? Can you read it to me again?
2 centers of bonding pairs
What does
and
that
an
mean?
axis.
Look at it. Pay
Uh-huh.
attention, please. This is a center of bonding pair, and that's center of bonding pair. It's not 3. But look at ammonia. How many centers of bonding pair do ammonia has?
3.
Thank you. 3.
Uh-huh.
There are 3 centers of bonding pair. For it to be linear, you must have 2 centers of bonding pair. Now, how many centers do water has?
2.
Why is water not linear? Why is it a non-linear molecule? Because there are lone pairs on it.
Yes, there are 2.
So it can't be linear.
Yeah.
So you must have 2 centers of bonding pair, and you must not have any lone pair on you again. Then you be linear. Is that correct?
Mm-hmm.
All the molecules are linear. Number 2, so 2 centers. So that's the condition. Is that okay?
Yes.
Number So let me go for number 2. Bent. Why did I put the name? Number 2 is bent or V shape or non-linear. Can be called by the name bent, V shape or non-linear. Bent, V shape or non-linear. To know that, I think I just did this. Hold on, please. Okay, look at it here. I was just I was explaining to you here. Okay, I'm not yet there. Look at it. Hello, are you there?
Yes, sir.
I was saying why H2O is not linear. Is that okay? Why?
Mm. You were
H2O
saying that it does have two centers, but it has lone pairs. That's why it's not linear.
non-linear because of two lone pairs. HOCl also, why is it non-linear? HOCl, non-linear, two lone pair, can't be linear, non-linear. Why? Two lone pairs. Am I right?
Yes.
Thank you. Why is this guy linear? Do you agree? 1, 2, 3, 4, no lone pairs again. The NOCl, why is it non-linear?
It has lone pairs.
Thank you. So non-linear, not linear. How about this also not linear? How many? Why is it? Give me three reasons why ammonia is non-linear. Ammonia is not a linear
It
molecule.
has three centers and lone pairs.
3 centers of bonding pairs and 1 lone pair. So it doesn't agree with the rule. The rule says you must have 2 centers of bond pair and you must have no lone pairs. So ammonia is not in linear. Carbon, what about this carbon? 4 centers of bonding pair. How many centers of bonding pair do you have? How many centers of bonding pair? This one is 4 centers of what?
Bonding pair.
What about the guy next? What about how many does he have? 3 centers. Am I right? Do you agree 3 centers
Yes.
of bonding pairs? What about here? 2
Two
centers. You know, of what?
lone pairs.
Of bonding pairs. You understand it now very well. And this carbon also too. So this is it. We've done this before. Hydrogen must have 1 bond pair. Am I right? We have done this before, me and you. Am I right?
Yes.
Yes, thank you. So that's gone. So let's go for number 2 now. Non-linear or bent or V-shape or angular. The perfect example of that is water. So what's the condition now? 2 what? 2 what? Read it. Look at the condition.
Two centers of bonding pairs and two lone pairs on the central atom.
So look at it now. Water, 2 bond pair, 2 lone pair. HOCl, 2 bond pair, 2 lone pair. OC, we have just replaced the, you know what? Going from here to here, I replace hydrogen with chlorine because the valency of hydrogen is 1, that of chlorine is also 1. So instead of that OHH, I wrote OHCl. Instead of writing OHH, I wrote OClCl. You see the same thing. Do you agree?
Yes.
And now replace oxygen with sulfur. They're in the same group, right? So anything that oxygen does, sulfur should also be able to do it. Do you agree? They both have 6 electrons in the outer shell. So H2S also non-linear. Sulfur dichloride non-linear. Hydrogen peroxide non-linear. Disulfur dichloride non-linear. Disulfur dichloride. What about this? Disulfur dichloride. Is that okay? Do you get? So 2 centers of bonding pair. So no. So central atom is this. So what's bond angle? Bond angle is what? Oh, go back to linear. What's bond angle of linear? It's something linear. What's bond angle? Some of us on the straight line is what? What is the sum of angles on a straight line in math?
180.
Thank you. So this is 180. Is that okay? So linear is 180. Is that okay?
Yes.
Linear is 180. Then what about non-linear, bent or V-shape? What do you say the bond angle is?
104.5.
You have to remember this value. So, but
Okay.
that value is only valid if the central atom is what? Is what? You are reading what I'm writing now. Central atom is what? When
Yes.
central atom is O, what's the bond angle?
What's the?
When the central atom is O.
The bond angle is 104.5.
Now, if you now replace it when the central atom is O. Now, come on. Now, when you now replace oxygen with sulfur or with selenium or with tellurium, what happens to the bond angle?
It decreases.
You have to know that. You are not supposed to know the value. Let me get number saying. What I mean is this. What's going on now? Oh, it's working, thank God. As in, come back here. Oh, water, hydrogen sulfide, hydrogen selenide, hydrogen telluride. Is that okay?
Yes.
You are not supposed to know their values. You have to know the value for water only. But you have to know that H2S is lower than water. And H2S, this is H2O. This is H2S, H2SE, H2TE. You have to know the value for water when it is oxygen. Other value, you are not supposed to know them. But you are supposed to know that as you go down, the bond angle decreases. Do you understand that? You are not supposed to. So 1 year they said, what is the bond angle in hydrogen selenide? Well, they said, what is the bond angle in what? They now wrote, come and say, they said, this question, let me tell me the answer. State OBJ, the approximate bond angles in hydrogen selenide. A, 180 degrees. B, 120 degrees. C, 90 degrees. D, 109.5 degrees. What's the answer?
C.
Thank you. Do you get the point now? They always say the value in theory. They will only ask you in multiple choice where you can use your common sense to figure out the answer. Do you get the point now?
Yeah.
You don't go and price any value. Your textbook may be stating the value, just ignore them. They will ask you an exam. You have to know the value for water. If it is water, what's the bond angle? 4.5. Is that okay? But as you go down the group, bond angle decreases. Is that okay?
Yes.
So this seems to make sense to you. Thank you. Now let's go on. So the bond angles decreases in that fashion. The bond angle decreases in what? In that fashion. Is that okay? Now, number 3 now is what? Trigonal planar.
3 centers.
Thank you. Go on. Yes.
3 centers of bonding pairs and absence of lone pair on central atom.
Now, Kamuda, this thing I say about the bond angle, it only decreases if there are lone pair on the central atom. Where there are no lone pair, bond angles don't change. I will give you an example now. Here there are 2 lone pairs on the central atom for bent or for angular or for nonlinear. These guys, there are 2 lone pairs on the central atom. So as you go down the group, other factors being equal, there will be a decrease in bond angle. Is that okay? If there are lone pairs, if there are lone pairs on the central atom, as you go down the group, there's a decrease in bond angle. I have to write it down so that you don't. Can do it.
Okay.
Tabla, can you give me 1 minute? I need to do something now. Just 1 minute. Just 1 minute. 1 minute, you. 1 minute, you. Theophilus. Theophilus. Where's your mommy? She signal. Signal. Okay, I'm back. I'm done. I'm back. Now, if bó ti ṣe bẹ́ẹ̀ wọ́n ti list bẹ́ẹ̀ ni shapes where there is one or more lone pair on the central atom, bond angle decreases down the group. Do you understand it now? I'm saving it. Kamina, do you understand it? In
Yes, sir.
shapes where there is one or more lone pairs on the central atom, there's a decrease in bond angle as the group is descended down the group. Is that okay? This guy, do you have lone pair on the central atom here? Trigonal planar. What are the conditions for trigonal planar?
Three centers of bonding pair, absence of lone pair on central atom.
So the meaning is, you look at it. So boron is period 2. Am I right? What about aluminium? Period 3. What's bond angle in BH3? Bond angle is what? Yes, is it already there? I didn't say that bond angle. It's there. It's 120. Look at it here.
120.
Bond angle. This one, whether you are going down the group or not, it's like triangle. Look at it. This is 120. Am I right? 120. 120. 3 centers of bonding pair, no lone pair at all. Is that okay? So BH3, Cl3, BF3, AlCl3. Look at it. What group is carbon? I'm looking at this guy now. How did I get to you? What group is carbon?
4.
Group 4. Is that group 4?
Yes.
It shares 2 with oxygen, 1 with chlorine, 1 with chlorine. At the end of the day, nothing for him again. 3 centers of bonding pair. Am I right? And there's no lone pair again. It's complete. Or you can go for this guy also. Same thing with this guy also. Carbon is group 4. It shares 2 with oxygen, 1 with hydrogen, 1 with hydrogen. Phosphorus is what group? What group is phosphorus? Group 5. It shares 2 with oxygen, 2 with oxygen, 1 with chlorine. What group is sulfur? Group 6. 2, 2, 2. Do you get all these guys? They are all trigonal planar structures. And the bond angle is 120 degrees. Is that okay?
Yes, sir.
Thank you. Now look at this. In chloromethane, because chlorine is more electronegative than carbon, the carbon chlorine bond now breaks in favor of chlorine. Chlorine goes with the 2 electron. The shape of this we are going to teach later is called, this one is called tetrahedra. Tetrahedra. If chlorine now goes away with the 2 electron, Mr. Carbon is now having 3 bonds only, and there are no lone pairs, so it's trigonal planar. Now, do you get the point? In the former one, carbon has 4 centers of bonding pair, no lone pair. That is called tetrahedra. I've not talked to that. I will teach you now. Now, the one that they form now, carbon has 3 covalent bonds, 3 centers of bond pair, and there is no lone pair. Is that okay? So it's trigonal planar. Is that okay? So you get the point now. What is it? Let's go back. What can you say about linear? Linear is what? 2 centers of what? Bonding pair, no lone pair. And the bond angle is 180 degrees. What about bent or V-shape or non-linear? 2 centers of bonding pair, 2 lone pairs on the central atom. If the central atom is oxygen, then the bond angle is 104.5. But if it goes to sulfur below oxygen, to selenium, to tellurium, bond angle decreases. Is that okay?
Yes, sir.
Number 3 now. We have trigonal planar.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So By my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajiotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
3 centers of bond pair, no lone pair. And that's if there is lone pair on the central atom, as we go down the group, the bond angle decreases. What if there are no lone pairs? The bond angle does not change. E.g., going from boron to aluminum does not change it. The first compound is called borane. Second, the boron trichloride, boron trifluoride, aluminum chloride, dichloride, carbon monoxide. It's okay, and methanol, etc., etc., etc. Is that okay? We're done with that.
Yes.
Now there's now pyramidal. Pyramidal example of that is ammonia. In ammonia, we have 3 centers of bonding pair, 1 lone pair. So and the bond angle will be what? 107 degrees.
Mm-hmm.
But if you now go from there is a lone pair on the central atom, am I right? Therefore, as you go down the group, there will be a decrease in bond angle. Do you agree?
Yes.
Good. Now look at water. Now look at how many lone pair the water has.
How many?
Lone pair do oxygen in water has.
2.
After reacting with H plus, how many lone pair we left?
1.
Thank you. So this guy, the first guy is what? Don't let the other one is pyramidal. Can you see pyramidal now? So H3O plus is like ammonia. Do you agree in terms of shape?
Yes.
H3O plus now have 3 bond pairs and 1 lone pair. It's like ammonia. Do you agree?
Yes.
So that's how it goes. So as we go down the group again, the bond angle decreases. From nitrogen to phosphorus to arsenic to others, it decreased down the group. Now, tetrahedra. In tetrahedra, there are 4 centers of bonding pair, no lone pair on the central atom. Do you get? Yeah, that one is normal. CH for all of it's for group 4 element particularly. Carbon with 4 bond, silicon with 4 bond, they're all called tetrahedra. Bond angles is 19.5. Is that okay? Now, silicon. But now there are no lone pairs on the central atom. So as you go down through the group, from carbon to silicon to germanium to tin, there is no change in bond angle because the bond angle remains constant at 19.5 because no lone pairs on the central atom. Lone pair on the central atom is one that will decrease bond angle. Is that okay? Here, no lone pairs on the central atom. Then again, so look at this guy now. Look at what group is phosphorus? Group 5. After sharing 2 with oxygen, 111, it doesn't have lone pair again. And it has 4 centers of bonding pair. 4 centers of what? Bonding pairs. Am I right?
Yes.
Then no lone pair, no lone pairs. So it's tetrahedra. This guy also is tetrahedra. Sulfur is group 6. It shares 2 with oxygen, 2 with oxygen, 1 with chlorine. There are 4 centers of bonding pair, and there's no lone pair again. Tetrahedra. Sulfuric acid also is tetrahedral. The sulfur atom is tetrahedral. Is that okay?
Yes.
Then when ammonia that has a lone pair, after reacting with H plus to form ammonium, there's a change of shape from pyramidal to tetrahedral. Do you agree? So 3 bond before ammonia, 3 bond pair, 1 lone pair. Now this guy is 4 bond pair, no lone pairs. So now octahedral now 6 centers of bonding pairs and no lone pair. 6 center of bond. This one means the broken line means is pointing away from you into the board. Do you understand what this diagram look like? Do you understand what it means like?
I don't understand the lines are now different.
Oh, hello. I have to. Me and you, we have to. And the day we meet, they're always evening. When are we meeting? Next week.
Next
What
week
time is it? Wednesday.
7.
So 7. Is 7? Oh, 7
Nice
your time, 7 your time, 6 Nigerian time. Is it 7 Nigerian time or what?
It's 6 p.m. for you.
Okay, but 7 p.m. for you. Now there's not like where I am. When I'm teaching you on Wednesday, tell me to demonstrate shapes of molecule for you. I want to understand what it means. I'll put on my camera. I'll now demonstrate for you. I'll go and I have stick that I use to still call them models. I'll bring them. I will demonstrate them for you. I can't demonstrate now because they're in Lagos. Is that okay? I'll demonstrate for you when I say without remind me. I'm done with it too, but I know them so that you can conceptualize it, what it means in your mind. You memorize it. Is that okay? You have to understand it better. Is that okay? So then now there's one that they mentioned that is not in this one I gave you. Let me see. Shapes of covalent linear, bent. Look at it here. Pyramidal is also there. Trigonal planar, tetrahedral. And now trigonal bipyramidal. What can you say about that guy? Look at the first one is group 5 element. So how many centers of bonding pair?
5. 1, 2, 3,
5.
4, 5.
What about lone pairs? What about lone pairs?
No
0.
lone pairs.
Thank you. When you have 5 centers of bonding pair and no lone pair, that is trigonal bipyramidal. We have, it's not here, they didn't put it here. So but that one has 2 types of bond angles. You can separate it. It's like it has trigonal planar. It now has linear that goes up and down. So there are 2 bond angles in this guy. What are the 2 bond angles in trigonal bipyramidal? 120 degrees and 90 degrees. Pay attention, please. Pay attention. Let me do. You can read. Look at it. This one, 120. This one, 120. This one, 120. Is that okay? Those 3 chlorine, they are on the same plane. They are plane. I have to demonstrate this thing for you. It makes sense. I have to demonstrate it for you. Leave it. Just do now. When there's a meeting, I will demonstrate it for you. I'll put on my camera. I can't do it now. I'll put on my camera. I'll demonstrate it to understand. Is that okay? Same thing with octahedra. So there are the 6 types of shapes of molecule that you have to know. Is that okay? Then after that, now say, read the shape. Now come and see this now. Let's go. Look at this now. Look at that number 1. Nitrogen is having 3 bond pairs and 1 lone pair. Number 1 is pyramidal. Bond angle 107. Look at, I'm reading the answer. Look at the answer here. Number 2, carbon is having 3 centers of bond pair and there are no lone pair. Number 2 is trigonal plane at 120 degrees. Number 3, oxygen is having 2 centers of bonding pair with 2 lone pair. It is what? Non-linear or bent 104.5 degrees. Number 4, carbon is having 4 centers of bonding pair and no lone pair. So that's a trihedral. Number 5, carbon is having 2 centers of bonding pair with no lone pair, linear 180 degrees. Number 6, boron is having 3 centers of bond pairs and no lone pair. That's diagonal planar. I just try to combine them for you. Is that okay? So I can conceptualize it. Is that okay? I put all of them for you here. So next thing, let me see the next thing. So I've taken care of this. Now, next thing in your syllabus. So we now see intermolecular forces in covalent molecules. I've done that because I'm not doing that. I've sent to you. Am I right?
Yes.
I'm not saying you have done this. So the only thing left here is what? Intermolecular forces in covalent molecule. Before that time, before I leave you, hold on. There's what we call repulsion within covalent molecule. Look at it. Each bond pair means 2 electrons. There are 2 electrons here. 2 electrons here. They are repelling each other. So when this is laid there, the bond pair repel themselves and they are far apart from each other as much as possible. That's why the bond angle is 180 degrees. The bond electrons in bond repel themselves so much that they stay at the most distant from, they stay in the greatest distance from each other. Is that okay? So BCl2, we have bond pair repulsion. Now look, pay attention. Okay, yeah. Oh, good. I will have to write this and join it to this. Thank God. Yeah. Repulsion within covalent molecules. Also, I know that when I come next, in fact, that intermolecular forces, repulsion within covalent, please pay attention to molecules. I'll show you 4 molecules. Please pay attention. Look at this guy, CH4. It has only bond pair, and they repel themselves equally. When it comes to ammonia look like CH4. The one of the bond pair is now a lone pair. Do you agree? Water is also like CH4. But 2 of the bond pair are now replaced with 2 lone pairs. Do you agree? Good. So what type of version do we have? Here we only have bond pair repulsion. Bond pair repelling each other. Why would they repel each other? Each bond pair contains 2 electrons. Electron here, 2 electrons here. They repel the 2 electrons here. They repel themselves as much as possible. They stay away from each other. Don't move close. Here we have. Here, what do we have here? No, let me label it with a different color. What do we have here? Lone pair, bond pair repulsion. Do you agree?
Yes.
Let me use this last one. Number 1, what is this?
Lone pair
repulsion. Thank you so much for that. What about this?
Lone pair bond pair repulsion.
Thank you. And this final one?
Bond pair.
Now, when all the bond pairs are there, and there's no lone pair, bond angle is 19.5 degrees. And that is tetrahedral. When one of them is now a lone pair, so the repulsion here Lone pair bond, yeah, that's green. The repulsion here is more than the repulsion here. I'm saying that lone pair bond pair repulsion is greater than bond pair repulsion. Do you get? So instead
Yes.
of everything to be 19.5 throughout, actually for this guy, this I want to show you the I want to demonstrate for this guy. Look up 19.5, 19.5, 19.5, 19.5, all of that 19.5. It's not flat like this. The way you saw it's not flat. It is tetrahedral. It's like a tripod with 3 legs. One now stay on top of it. It's like you look at tetrahedral means you look at the carbon, there's a carbon here. Goes up on the number. This guy points away from you. You point to the screen. This guy points towards you, away from the screen. I will remember it to make sense to you. Don't worry, it will make sense to you. I'm just trying to tell you that this thing is not as flat as the way I drew it here. Because this is a single plane I'm drawing. Is that way? It doesn't make sense. You can even go on and say shape, tetrahedral shape. They're going to show you the how it looks like exactly. Is that okay? Now let's go on. This guy do. So without saying the bond, instead of 19.5 throughout, this guy may now become 111. Then this guy would have become maybe what? Maybe 107. Do you get the point now? It becomes smaller. Because there's a greater repulsion between the lone pair and bond pair. This guy may now become also 111. Do you get the point now? I'm just an example. So if they ask you, why is the bond angle in ammonia lower than that of methane? What will be your answer? Ammonia has both lone pair bond pair repulsion. Ammonia has lone pair bond pair repulsion. In addition to bond pair repulsion found in methane. And lone pair bond pair repulsion is stronger than bond pair repulsion. Therefore, coming from methane to ammonia, the bond pair are pulled closer to each other. So the angle between them will decrease. Do you get?
Yes.
Is that okay? When that come together, it's stronger. This guy has what? Lone pair bond pair repulsion in addition to what? Bond pair repulsion. Let me write this in black so that if all the same trend, all of them throughout. Same repulsion, same repulsion, same repulsion, same repulsion. That's bond pair repulsion, only bond pair repulsion only. What about this one? Both lone pair repulsion, then bond pair repulsion. And the last one, we have lone pair repulsion. Lone pair repulsion, which is greater than what? Lone pair bond pair repulsion, which is now greater than what? Bond pair repulsion, bond pair repulsion. Can you see now? So the more the lone pair you have in the molecule, you know what the bond angle. Do you get the point now?
Yes.
The more the lone pair you have in the molecule, other factor being equal, the lower the bond angle. I mean, the more the lone pair on the central atom, other factors being equal, the lower the bond angle. Do you agree? So as the number of lone pairs increases, bond angles decrease. Is that okay? Now let me get another example so I can understand. Look at this. Look at this guy. Ammonia. What shape of ammonia? Trigonal pyramidal. If ammonia now reacts with H plus, what will it form? H, N, H, H, H.
Right.
Then this guy now say, no, I want to lose. Hydrogen goes away. Let me see if I can understand it. I didn't say I'm going away. I'm stronger than you. Then leave the electron behind for me. Don't even try. Just leave it behind for me. You want to go, bye bye. And then I now be like this. 1, 2, lone pair. Then that red bond between H and N before. It's not a lone pair now, right? I didn't now say I've gone away. Bye bye. I didn't say I've gone plus H plus. You can only now carry negative. Because it has gained electron. Do you agree it has gained electron?
Yes.
That red bond between H and N, who owned the 2 electrons that was there before? Who owned it? One from H, one from N. Am I right? H
Yes.
now goes away. Now left the 2 electrons behind. So hydrogen has gained how many? Nitrogen has gained how many electrons? Pay attention though. Are you listening to me?
Yes, sir.
There are 2 electrons here before, which originally one belonged to nitrogen, the other to hydrogen. When hydrogen wanted to leave, nitrogen said, you can leave, but you leave your electron behind for because I'm stronger than you. I am more electronegative. I'm going to take your 2 electrons. I did not leave the 2 electrons behind. How many has nitrogen gained now?
2.
1. The 2 electron, one originally belongs to him. One belongs to hydrogen.
Okay.
So he's
Yes.
taking the 2 now. He has only gained 1. Do you agree? So that's I carry minus 1. There's no carry
Okay.
minus 1. Do you understand now?
Yes.
Yeah, now. So what do we have here? We have this 3 guy. We have the shortest bond. Which one we have the lowest bond energy? Bond angles. The 3 of them. This guy is called amide ion. Amide ion. This guy is called ammonia molecule. Ammonia is a molecule. This one is ammonium ion. Ammonium ion. Which of them we have the highest bond energy? Bond angle. Don't forget, the more the lone pair, the lower the bond angle. This guy is 19.5. This guy is 107. This guy 104.5. Can you see? This guy is bent or V shape. This guy is pyramidal. And this guy was tetrahedral. Do you get the point? So the more the lone pair, the lower the bond angles. That's what I'm trying to tell you. The more the lone pair, the lower the bond angles. Is that okay? And the repulsion of this molecule can either be lone pair, and I've compared the 3 for you. Look at this 3 also. CH4. Look at carbon, nitrogen of the same period. So the radius is similar. Is that okay? The carbon has 4 bond pairs, no lone pairs. Bond angle is maximum 19.5. Nitrogen has 3 bond pairs, 1 lone pair. That decreases bond angle a little bit. Water has 2 bond pairs, 2 lone pairs. That decreases further. Is that okay? So the more the lone pair you have in the molecule, other factors being equal, the lower the bond angle. Do you understand that?
Yes.
I think that's, let me see where we start now. So I've taken up to this point now. I'm done here. The next thing to take is this.